Hello and welcome to the Sociology 3 Module 14 video lecture on interpreting and evaluating statistical claims. In the last module, we focused on interpreting and evaluating causal claims. This week, we're going to look specifically at when authors use statistics as a form of evidence. How can we critically interpret and evaluate statistical evidence? So first, let's get clear what statistics actually are. So I'm sure you all knew this. You've been talking about statistics in your math classes, probably going all the way back to late elementary or middle school. So for the purposes of this course, we're going to talk about statistics specifically as a form of evidence that is expressed as numbers, so quantifiable evidence. Quantify, think of quantity, a number. So a couple of examples here. 48% of all American marriages eventually end in divorce. It actually is a little bit lower than 50%. Here's another one specific to our student body here at Fresno State. In 2013, 40.6% of all Fresno State students identified as Hispanic. The thing about statistics is, excuse me, they often make evidence appear very authoritative, precise, scientific, and especially objective. So unlike reporting evidence that seems to be based more on subjective experiences, when you put something in that numerical form, that quantified form, it has this aura of authority. And we need to be critical thinkers about that because sometimes statistics don't always reflect the most accurate kind of information about a topic. And the reason for this is that statistics can be deceptive. So one of our primary jobs as a critical thinker and as someone who's trained to ask particular critical questions is that we have to be able to detect deceptive statistics. In other words, we don't ever want to let numbers speak for themselves. So we always want to ask ourselves the critical question when we come across a piece of statistical evidence: how did the author arrive at this particular statistic? Now, there are a lot of obstacles to creating accurate statistics, and this can lead, these obstacles can lead to statistics being inaccurate reflections of what's actually going on out there in the social world. So the first one, we've talked about this before, a lot of key terms can be very ambiguous. They can have different meanings. So when we ask people questions, say in a survey, which is one of the primary methods where we get a lot of our statistical evidence, words can mean very different things to two different people. So that ambiguity can pose a challenge. People who create statistics often face obstacles in identifying relevant persons or events. Who do we survey? What kind of events do we observe? Sometimes people are unwilling to provide truthful information. This is probably not going to come as a shocker to you that not everyone accurately reports information on surveys. Sometimes people are very willing to be honest, but there's some difficulty in remembering events, what actually happened, and sometimes they can't accurately report them because their memory is faulty. There are also a lot of physical barriers to direct observation. So when we're trying to create statistics based on observations, a lot of times we as researchers can't directly observe them. So we always want to be careful to ask ourselves, how was this statistic created? What kind of questions were asked? How were those questions worded? Did those questions use any ambiguous terms? And did people accurately report information on the surveys? Another problem that we face when thinking about and evaluating statistics is this concept of an average. Another word that you're probably very familiar with, but one that has multiple meanings. And it's really important to talk about these multiple meanings because depending on how an author is using average, what particular definition or type of average that author is referring to, it can really influence what the author is trying to argue, the conclusion that the author is trying to make, and then how good the evidence that he or she is providing, how good that evidence is. So, very common word that we often hear, but one that has multiple meanings. Some examples. The average student is X, or on average college students do X. We're usually talking about what's typical Now in statistics, if you've ever taken a statistics class, average refers specifically to a measure of central tendency. And there's a particular type of average that statisticians most often use, and we'll talk about that on the next slide. But the reason it's so very important to think about the different meanings of the word average is because if you think about it, so much statistical evidence, so much information about social trends is reported in terms of averages. So here are just a few examples. The average household in the United States makes $51,000 a year. Did that number seem low or high to you? And that is indeed the average income for American households. The average American woman is 5'4". Interestingly, I didn't include this on the slide, but the average American man, do you know how tall the average American man is? He's 5'9". African Americans are, on average, less likely to graduate from college than Asian Americans. So these are just some typical statistics that rely on the concept of an average to convey information. But we have to critically think about averages, because when an author reports a statistic in terms of an average, you absolutely have to ask yourself the critical question of what kind of average is he or she using? Because there are actually many different kinds of averages. So if you've taken a statistics class, you're probably familiar with the word mean. Sometimes this is referred to as a mathematical average. When you take all the values on a particular variable, you add them up, and then you divide by the number of values. So for example, if I was going to calculate an average on a class assignment for our Stage 3 course, I would add up all of the scores that all of you made, and then I would divide it by the number of students in the class. But there are a couple of different additional ways of looking at what an average is. The median is also another very common way of reporting an average, and that is the midpoint value of all numbers in a particular data set. So you can think about the median as if you listed all the values on a particular variable. Say if you listed all of the values that each student in our class of 100 people made on a paper, the median would be the midpoint value. Where in that ranking of numbers is the midpoint, where half of all people scored above that number and half of all people scored below. There's also something called the mode, which is the most common number in a data set. So this is just the most typical value. So say that it was an assignment that, like your sociological editorials, that was worth 30 points, and the most common grade of all 100 students was a 26 out of 30. That would be considered the mode. A couple of tips for figuring out what kind of average an author is referring to. So going back to our example of the average American household income is $51,000 a year. Half of all U.S. households make more than $51,000, half make less. So if you have an author that's reporting an average in these terms, using that half-half language, this usually means that the author is reporting a mean. Now you may be asking yourself, what is the value of using a median? What would be the value of using median as an average rather than a mean? Well, if you guess that the median is less influenced by either very high values or very low values, you would be absolutely right. And we call those outliers. So the statistical average, or the mean, is actually influenced very heavily by very high or very low scores. And the median, because it's a ranking of all values and indicates that midpoint value, the median is actually not as influenced. So it's a better way of giving us a sense of what the midpoint value would be without being influenced by outliers. If the author is referring to a typical experience, he or she is likely referring to the mode as a type of average. So if we say the typical student at Fresno State takes 15 hours or 15 units of coursework per semester, what we're saying is that that's the most common course load for students at Fresno State. That if we surveyed all 21,000 of you, 15 units or 15 course hours would be the most common course load. We also want to know about two additional values called the range and the distribution. So the range is the difference between the highest and the lowest values. So remember when I talked a moment ago about the median, how the median, unlike the mean, is not as influenced by outliers? We often want to know the range for similar reasons. So what was the highest value? You might want to know, as I often did, what was the highest value on the class exam and what was the lowest, to figure out where you fit within that range. People also should be very interested in what's called the distribution, or how frequently each of the values, particular values, occur. So here's an example from Brown and Keeley, very sad example. Doctor is speaking to a 20-year-old patient, and he tells her, the prognosis for your cancer is very poor. The median length of survival is 10 months. You should spend the next few months of your life doing those things that you have always wanted to do. Well, if this patient was, after getting such bad news, could put their critical thinking skills to use, one of the questions that this person should ask is, okay, well, the median length of survival is 10 months, but what that means is half of all people don't survive to the 10-month mark, but half of all people do. Remember, median captures that, the half and half of the midpoint value if you rank them all in order. So that could mean that a lot of people, if you were given this particular cancer diagnosis, might live to be 50, 60, 70, 80 years old. And that would be one of the reasons that you would want to know both the range, so what's the highest and the lowest values. Are there some people who live only a month? Are there other people who live to be 80? That would be very important information for helping you figure out the prognosis here. We'd also want to know the distribution in this case. Is it more typical that people with this prognosis live to, say, a year after the diagnosis, or is it more typical for people to live 5 years and 10 years? This gives us a little bit more information about the full set of values that average, in this case the median, is based on. We also want to pay particular attention to how statistics are worded, especially because we want to ask ourselves, okay, given what type of statistic, what piece of evidence the author is presenting, is the statistic he or she is providing, does it actually match the conclusion? Does it actually support that particular conclusion? And when you pay attention to wording here, sometimes the author is actually providing the statistic that doesn't support his or her conclusion. You want to make sure essentially that they're referring to the same thing. Do the conclusion and the statistic match? So here's an example. More than half of American college students have cheated on a paper or exam. A researcher recently surveyed students at Fresno State. Of the 100 students who completed a survey, 90 admitted that they knew of a friend or relative who had cheated at least once in college. So the conclusion the author is wanting you to accept is more than half of American college students have cheated on an exam or a paper. The piece of evidence that he's offering is based on a survey in which 90 of 100 people admitted that they knew of a friend or relative who had cheated. So you want to ask yourself, wait a second. So is this piece of evidence, does it actually support the claim that more than half of American college students have cheated on an exam or paper? And your critical thinking red flag should go up and you say, wait a second. The survey actually refers to people who knew a friend or a relative, but the conclusion the author's trying to make is that college students, right, that more than 50% have admitted to cheating themselves on a paper or exam. So in this case, no, the statistic and the conclusion don't actually match. It would be the author's responsibility to actually provide a statistics, perhaps based on a survey, where people reported whether or not they themselves had ever cheated on an exam or a paper. So authors can be pretty tricky. Sometimes it'll seem like it's on the same topic, but as in this case, they're actually, the statistic and the conclusion, they're actually referring to two different things. We also want to be very mindful of certain pieces of omitted information, what's left out. And you want to ask yourself, what additional information am I going to need to make sense of this statistic? In most cases, you need both percentages and absolute numbers